So where does completing the square actually come from? Well, we know that a plus b quantity squared is a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. We know those. Okay? And the whole point of completing the square is to go from some expanded form into a more compact form like this, something plus or minus something squared. Sometimes it makes solving equations easier. That's why this is a technique that's useful sometimes. Okay? The problem is we don't always have this nice relationship. We don't always have this type of form in order to factor as a complete square of something plus something or something minus something. That's the problem. So what if I replace this b with a b over 2? Okay, so this becomes a b over 2, and this becomes a b over 2. If this is a b over 2, the 2 on the bottom and this 2 cancels, so I have just ab, and this I left alone. So this term should look very familiar. This is the term that you add when you complete the square, and this is exactly where it comes from. For some arbitrary something squared plus something times another something, if we take that second something, divide it by 2, square it, then we can write it in this factored form over here. This is exactly where completing the square comes from. Okay? And if you notice, there's a rule where when you complete the square, the term in front of a over here has to be 1, and that's where it comes from again. You can see, in order for this to work like this has to be a 1 there as well. Okay, so if we quickly look at this simple example, x squared plus 2x, if we want to complete the square here, first you got to check that the term in front of the squared term is 1, which it is. It's 1x squared. That's good. Now we take the term in front of the x to the first power, which is 2. If it's a minus 2, you take the minus sign as well. 2, you divide it by 2, and then you square it. And then you subtract it back right away because this line has to be equal to this line. So if I just add it, I'm adding 1. Then it becomes x squared plus 2x plus 1. That's not the same thing as the original guy. So you have to subtract it back right away for it to be equivalent. Okay. Now this, if you factor it, x squared plus 2x plus 1, you know that it's x plus 1 squared. But we don't have to actually write out x squared plus 2x plus 1 because this is, again, the whole point of completing the square. We're adding this term. So we can directly take this b over 2, or this 2 over 2, and put it right here. We know b is 2 and a is x. A is x, b is 2. Okay? So we can directly write it as x plus 2 over 2 squared minus 1, or is x plus 1 squared, as I said earlier, if we had factored directly x squared plus 2x plus 1. Okay? And then we have the minus 1 because, again, we're subtracting the term we added right away. So that's equivalent, okay? So this is what happens when we complete the square. And we could check that it's equivalent to this one more time if we just expand this out, of course. It's x squared plus 2x plus 1 minus 1, which is x squared plus 2x. Exact same thing. So once again, we're using this very well-known formula to our advantage. We just replace this b with a b over 2, and that's where that term comes from. That term that we add when we complete the square, that is where it comes from.